Hello, everyone. Hope you're all doing well. We're going to take a few minutes here to go over quiz 7. Now, quiz 7, like all quizzes, is a mixture of basic skills problems and advanced skills problems. So what I'll do is go over the basic skills problems first, and then we'll come back and do the advanced skills problems. So I would consider the advanced skills problems to be part C of number 1, part D of number 2, and part A of number 3. So like I said, we'll save those till last. Now for number 1, part A, it asks what is the proportion? And you're given two numbers in this description, the 1329, the 2253. So you just divide 1329 by 2253, and you get 0.59. That's the proportion, and it was computed from a sample, so the symbol for the sample proportion is p hat. In part B, it asks, is this a parameter or a statistic? Anything computed from a sample is a statistic, so statistic. Okay, let's skip over C temporarily. Go on to number 2. Number 2 is based on a survey of 2,986 Americans. And in part A, we're asked how many of these are book readers, defined as having read at least one book in the past year. And we're told that 80% of those surveyed have read at least one book in the past year. So here's a simple calculation. We want to find 80% of 2,986, so we just multiply 2,986 by 0.80, round the answer off to the nearest whole number, and that would be 2,389. In part B, it says it gives values for the median and the mean, and you see the mean is just about twice as large as the median. Why is that? What does it tell you about the distribution? Well, we can imagine that among these book readers, most people might read a few books a year. But there's a relatively small portion of those who are avid book readers who read many books each year. Now, if we were to make a dot plot or a histogram, we would likely see a right skewed distribution. The right tail would represent those few readers, those few avid readers who read lots of books every year. Now, we've learned back in chapter 2 that in a right skew distribution, the mean is pulled in the direction of skewness. So that's why we would expect to see the mean to be greater than the median, because it's not resistant to those extreme values. They are part of its computation. Okay, then in part C, 17, well, we were told that that's the mean that was computed from the sample, so that's a statistic, and it's a sample mean, so the symbol for that is X bar. In part D, we're going to skip part D for now, and we're going to skip part A of number 3. So we'll go on to part B of number 3, and it asks us to estimate the true value of the population parameter, or proportion in this case. And to do that, all we need to do is look at this sampling distribution and find the number on the horizontal axis that looks like it's right about in the center. So to my eyes, it looks like 0.32 would be a good estimate. So we would just say, from the sampling distribution, it looks like 0.32 is the best estimate of the population proportion. For part C, we're given 4 different possible values for a sample proportion, and we're asked to tell whether they are reasonably likely to occur, or just somewhat likely to occur, or extremely unlikely to ever occur. Starting with 0.30, if you locate that on the horizontal axis, you see above it in that area lots of dots. So that tells us it's reasonably likely to occur. 0.20, on the other hand, Doesn't even show up on the horizontal axis. It's a little bit far off to the left. So obviously no dots near it. Means it's extremely unlikely to ever occur. For 0.37, we can locate it on the horizontal axis, but above it and nearby, there's only a relatively few dots. That's telling us that it can occur occasionally, so it's somewhat likely, but it's not highly likely to occur, but it can occur occasionally. And then finally, the 0.74, that is so far off the graph, so far to the right, that there would be no dots anywhere near it, meaning it's extremely unlikely to ever occur. Then in part D, it says, estimate the standard error of the sampling distribution. And you may have been confused by the term standard error. It's simply the word or the term that statisticians use for the standard deviation of the sampling distribution. So all we have to do here is use that method that we learned in chapter 2 for estimating the standard deviation given the dot plot of a distribution. So remember how that goes. We first find two values on the horizontal axis that look as if roughly 95% of the dots lie between those two values. And to my eyes, looks like it could be 0.28 and 0.36. So we find the difference between 0.28 and 0.36, that's 0.08. And remember then we have to divide it by 4. So 0.08 divided by 4 is 0.02. So 0.02 is our estimate of the standard error. And then in part E, it asks, what if we increase the sample size to 1,000, up from 500 to 1,000? Would our estimates tend to get more accurate or less accurate? Would the standard error be larger or smaller? Well, it's a basic principle in statistics that as the sample size increases, the variability of the sampling distribution decreases, meaning that our estimates tend to get more accurate. And since the standard error is a measure of the variability, as the sample size increases, variability decreases, so then we would expect the standard error to decrease, so it would be smaller. Okay, now we'll go back and look at first number 1, part C. So let me see here, I've got a slide. In part C, it asks us to describe in words the parameter that's being estimated. And this is similar to number 2, part D. So in each one, what I would do first is make sure you understand what the population is. So here, since the sample was a sample of US adults, it's reasonable to assume that the population is all US adults. And then, since the statistic was the proportion of the sample who use a search engine every day, the parameter being estimated is the proportion of all US adults who use a search engine every day. Now the symbol for that, for the population proportion, is simply the letter P. In number 2, part D, again, we want to begin by defining the population. In this case, it's all Americans who have read at least one book in the past year. And the statistic was the mean number of books read. So the parameter being estimated is the mean number of books read by all Americans who have read at least one book in the past year. Symbol for that is the Greek letter mu. If you're writing this out on a test or using a word processor or something, if you don't know how to insert mu, you can just put mu. For number 3, part A, it asks, what does each dot on the sampling distribution represent? Now you see, we've had dot plots before. In dot plots we've had prior to this, each dot was just a single data value. But what's new here in chapter 3 is the idea of a sampling distribution. And with a sampling distribution, each dot represents a statistic computed from a sample. So for this particular example, each dot in this sampling distribution is the proportion who have never been married in a random sample of 500 US citizens. So just imagine selecting many different random samples of 500 US citizens from all US citizens. And for each random sample, computing a proportion. So the proportions would not all be the same. They would vary from sample to sample. And that's what we find when we make the dot plot for the sampling distribution. We find a pattern of that variability. Now, it's important to note, 500 is the size of each sample. It's not the number of dots. The number of dots is pretty much arbitrary. You could make a dot plot, in this case, with 1,000 dots or 100 dots, however many dots you want. Each dot, though, would represent a proportion from a random sample of 500 US citizens. So that's quiz 7. I hope I've cleared things up for any of you who are confused. Anyway, stay well and see you next time.